Hello everyone, I am Dr. Vivek Saxena. In this lecture, we will cover the topic of mesh analysis. This one is the main topic of this subject, fundamentals of electrical engineering. Mesh analysis is based on KVL. According to KVL, in any mesh or loop, the algebraic sum of all the voltages is equal to 0. To understand the concept of mesh analysis, we will take an example. As you can see, in this circuit, we will apply the mesh analysis method to find voltage or current in any element of the circuit. As you can see, in this circuit, firstly, we will find the number of mesh. Now, if we talk about the mesh or loop, what is mesh? Mesh is the smallest closed path of the circuit. As you can see, in this circuit, there are two mesh. First one is this one, and second one is this one. And if we talk about the loop, any closed path of the circuit is known as loop. It means this circuit consists three loops. First one is this mesh, second one is this mesh. This one is also called as loop. But if we remove this per common branch, then it would be another loop. It means it consists three loops. Now we will start to apply the mesh analysis. For applying the mesh analysis, firstly, we have to find the number of mesh. In this circuit, it has two mesh. We have marked here, this one is our first mesh and this one is second mesh. After that, we will assume current in these meshes. As you can see here, I have written here I1 in mesh 1 and I2 in mesh 2. Both the currents we are assuming here in clockwise direction. You can take first one is clockwise and second one is anti-clockwise, or both the currents in clockwise or anti-clockwise direction. These are unknown currents and you are free to assume the current of assume the direction of such currents. It may be both the currents may be in clockwise direction or anti-clockwise direction, or we can take first current in clockwise and second current in anti-clockwise direction. We are assuming here two mesh. Now we are applying KVL in mesh 1. In mesh 1, as you can see, we are applying KVL. For applying KVL in mesh 1, firstly, we have to add all the resistances that are associated with the mesh 1. In the mesh 1, there are three resistances, 5 ohm, 3 ohm and 4 ohm. So firstly, we will add these resistances 5 plus 3 plus 4, that is 12 ohm. Now we will multiply the sum of these resistances with I1. I1 is the current that is main current is flowing in this particular mesh. After that, we will find the common resistance of this mesh that is associated with the another mesh. As you can see here, in 5 ohm, 3 ohm and 4 ohm. 3 ohm is the resistance that is the common resistance in between mesh 1 and mesh 2. In this particular 3 ohm resistance, we will write here and multiply by the current that is flowing in this particular resistance except I1. So that would be I2. Now we will talk about that what sign we have to put here. It would be plus or minus. It will depend upon the direction of current that would be flow in this particular resistance. As you can see, we are applying KVL in this particular mesh. That's why I1 we have taken as a positive. That's why I2 will be in the opposing direction of I1 in this particular resistance. That's why we have put here the minus sign. Now we will find any other resistance is common to any other mesh. No, there is no resistance that is common except 3 ohm resistance. Now we will put here the equal sign and we will find the voltage source, the voltage sources that are associated with this mesh. In this particular mesh, there is a voltage source of 20 volt. We will write here the value of 20. It would be positive or negative. It would depend upon the direction of current that is associated with the mesh 1. As you can see, the current we are assuming in clockwise direction. It means current is flowing from lower to higher potential. That's why we have write here plus 20. After simplifying this equation, you can see here this one is 12 I1. 12 is the total sum of these resistances that are associated with the mesh 1, and 3 ohm is the resistance that is common in between mesh 1 and mesh 2. Minus 3 I2 is equal to 20. 20 is the voltage sources that are associated with the mesh 1. So this one is the equation 1. Now we will apply KVL in mesh 2. In mesh 2 again we will do the same process as we have done in the previous mesh. Firstly, we will add all the resistances that are associated with the mesh 2. These are 3 ohm, 2 ohm and 1. It means 3 plus 2 plus 1, it means 6 ohm. And the multiplied by the main current of this mesh, that is I2. We have multiplied here 3 plus 2 plus 1 multiplied by I2. After that, we will again find the common resistance of this mesh that is associated with any other mesh. So there again, this one is 3 ohm resistance that is common in between mesh 1 and mesh 2. That's why we have right here 3, and the current except I2 that is flowing in 3 ohm resistance, that is I1. Again, we have put here the minus sign because we are assuming I2 as a positive current. It means we have to take I1 as a negative because in 3 ohm resistance, I2 is flowing from downward to upward direction while I1 is flowing from upward to downward direction. That's why if we are taking I1 as a positive, it means we have to take I2 as a negative. In this expression, in equation number 2, you can see here, if we are taking I2 as a positive, it means the current, the symbol of the sign of I1 is minus. Again, we will put here the equal sign and find the voltage sources that are associated with this mesh. In this particular mesh, the voltage source is 5 volt. We will put the value of minus 5. Why we have written here minus 5? Because when we will moving with the direction of I2, you can see here I2 will flow from higher to lower potential. That's why we will put here the minus sign. Now these are the two equations. After applying KVL in mesh 1 and KVL in mesh 2, the simplified equations are 12I1 minus 3I2 is equal to 20 and 6I2 minus 3I1 is equal to minus 5. After solving these equations, we will find the value of I1 and I2. You can see here the value of I1 is 1.66 ampere and the value of I2 is 0 ampere. These are the mesh current. Now, if we want to find the current in any particular branch of this circuit, then how it can be found? Then first, like we have to find the current in 5 ohm resistance. It means only I1 will flow in this particular resistance. Then the value of current in 5 ohm resistance is I1 is equal to 1.66 ampere. Similarly, the value of current in 4 ohm resistance is I1 is equal to 1.66 ampere. If we talk about the current in 3 ohm resistance, it would be the algebraic sum of I1 and I2. The value of current in 3 ohm resistance is I1 minus I2, or you can say I2 minus I1. If we are considering the direction of current in 3 ohm from upward to downward direction, then it would be written I1 minus I2. And if we are assuming the direction of current in 3 ohm resistance in upward direction, then it would be written I2 minus I1. The final current of this 3 ohm resistance is, if we are taking upward to downward direction, then it would be I1 minus I2. Then it would be I1 minus I2 means 1.66 minus 0 is equal to the 1.66 ampere. Then if we are finding the current in 2 ohm resistance, then it would be I2, and I2 is 0. Then the final current of 2 ohm resistance is 0. And similarly, the current in 1 ohm resistance is 0. As you can see, with the help of KVL, applying KVL, in the mesh analysis method, we can easily find the current or voltage in any particular element or branch of the circuit. These are the reference books. Thank you.